All right, how y'all doing? How was the project? Ah. Everybody get it in? Good. You know what that means? Another project. What are you going to do this time that you might not have done last time? How many of you didn't start early and wish you had? Didn't I warn you? Didn't I say that like the first day? Here's a consolation prize. Okay. So, new project. So, in our theme for this semester, we are helping a vaccine study, and the first thing that we've done here is we have written a program so that people out in the field can enroll subjects into the program, right? They go out, they recruit pregnant women, they get their history, and they enroll them in the study. Well, what's going to happen as part of this is that your program is going to be distributed to a variety of research sites all around the world in different places. And the reason that the research takes place in different places is for two things. First of all, is different places in the world have different genetic strains of diseases, so the viruses are a little bit different from place to place around the world. And also people are different from place to place around the world. They have different genetic backgrounds, different diets, and things like that. So when they do these studies, they do them kind of all over the place at the same time, and they have a whole bunch of different sites to do this in. Okay? So the second thing that we need to do is we need to help out the researchers who are doing the recruiting at different sites around the world. All right? And what they're going to do is they're going to go out and they're going to recruit more or less 100 people as their goal to get them into a single cohort to participate in the study. But what we need is some way of checking the cohort to make sure that that particular cohort is useful, right? That there's not too many people who have a score of 0 or other limiting factors, and that they can take a look and make sure they're getting enough subjects that are going to be part of the experiment. So I'm going to show you what you're going to get back. You're going to get back a file. And the file will look like this. This one is subjects from Lima, Peru. Any of these numbers look familiar to you? Yeah, I heard that. Okay, so we get about 100 subjects, and each subject is represented by the output of the program that you just finished writing. Okay? Now what we need is we need some way to analyze the data of all these 100 subjects to see how many have scores of 0, what the average score will be, things like that. All right? How can we do this? Writing a program. And so how is our program going to differ from the last program, though, in one important way? Yep. All right, so your suggestion is that we want to take the numbers in without manually inputting them. What's wrong with typing 100 lines of 13 fields each? What could possibly go wrong? Severe arthritis, yes, repetitive strain injury, and errors. People really are bad at typing numbers. They are, okay? So we want some way to read the file in. So that's exactly what the program solution that I have written does, and we can take a look at that. Oops. All right, so what it's going to ask, what your program's going to ask for is a file name for loading data from. What do you think this is going to be, by the way? Like when you input this. What type is that? It's text, and what do we store text in? A string, okay, string, okay. Please enter a maximum subject score. What this is that if they set a particular score, people above that score will be excluded. People with a score of 0 will also be excluded. So let's say we just set our score to something like 33.2. Okay? Now what's going to happen is the computer's going to read that file, calculate statistics, and display them. Oh, it's done. Okay? And here's what comes out. The number of subjects who are excluded because they either had a score of 0 or a eligibility score above 33.2. It's going to show the number of subjects who are qualified to participate in the study, and then averages for each one of the factors that we've seen and computed. It's also going to have the average eligibility score and the minimum and maximum eligibility score among those who are eligible. Right. So as of like 4 minutes ago, this should be posted on Blackboard. There are two parts to this assignment. Anybody want to guess what the first part is? Design. And what's the second part? Which is more fun? Design is more fun? Okay. So that's what we're going to do. Any questions so far? You can go online, you can read the assignment. This is available again for you to run. It's on CS class on my account. You'll be able to run and experiment it. I put this particular file of subjects on there as well, so that you can use that for testing, or you can create your own. Any questions? Yeah? The sample set you have is for everybody to work from. If you ask me nicely, I might build some other sample sets for you. I have written programs. So you're writing one program. For every program you write, I write like 4. Because I write one to grade it, one to create data, one to do other stuff. All right, maybe I only write 2. I exaggerated. But I write at least 2 more programs beyond what you write. So I do have a program that will generate these data files for you if you want some. And in fact, when I write the autograder will do what it did last time, which is generate some data files and then compare yours against mine, okay? Among other things. Yes? Good? All right, so the design is due 1 week from today. There's only one thing about next week. What happens next week? We do not have class on Monday, okay? So I would like to talk about, from the C++ point of view, some of the stuff that we need to be able to do this. In particular, getting data out of files, okay? Because we're going to need to be able to get data out of files for this. How many of you are excited? How many of you are still thinking of dropping this class? It's okay. I do every day. So. All right, so is that typeface big enough? Yes. So the question is, there is curiosity why we're using .cc and instead of .cpp. Do you remember the video I just showed you at the beginning of the thing? What was that? Was it the evils of Microsoft? Everybody in the world uses .cc except Microsoft, who uses .cpp, Windows. So if you come from a non-Windows background, you just tend to use .cc. Is that okay? All right, is that typeface big enough for you all to see? You want it bigger? All right, so here we are. We're going to write a program, and it's going to be able to take input from a file. All right? Any guesses on what we need to do to be able to read input from a file? Yeah. We have to format the file correctly. That's true. But in our program, anything we have to do in particular? Absolutely. We have to include the right thing for us to read from a file. And in this case, it is #include fstream, which you can think of as a file stream. Okay, that's fstream. All right, so here is what we're going to do. We're going to write a little program, and here's our program algorithm. And I'm just going to comment it out. This is actually how I program when I'm programming. This is how I do my outline and my design. I actually do it in the comments. All right, like this. So this is our basic algorithm. We're going to ask for a file name, we're going to read from the file, and we're going to output what we read. Okay, so let's say we're going to ask for a file name. What do we need to think about in terms of asking for a file name? Okay, so we have to output a prompt so that the user knows what we're asking for. And then what? Great. Seeing file name. Now, did we declare this file name anywhere? Should we declare that? So what are we going to declare? Right up here. What type is it going to be? All right. So declare it and initialize it. So who got into trouble this last project, not initializing anything? At least a couple of you. So always happens. That's why I always try to initialize things. Okay, so good. We're good so far, right? Yep. Pardon? You're right. I forgot the string, the pound include string. Here. Ah. I only have nuts today. I'm really sorry. I owe you one. So the compiler would have reminded me of that shortly, probably. Okay, so now we can use string safely. Okay. All right, so now there's some stuff that we need that you don't know about. So let me explain it to you. You all know CN, right? How many of you all know CN? Great, you all know CN. Everything that we're going to do is going to work just like CN, except we have to define the source of the data, okay? CN, by default, takes data from the big hairless monkey pounding on the keyboard, right? That's where it comes from. For other things, and because that's common enough, that's just like part of what's defined in part of the language. For other things, we're going to have to define where the data is coming from. And the way we do this is we do this for input with what's called an IF stream, which is an input file stream, and we can name this something like, oh my gosh. It stopped. Nobody's turning red. I'm not sure who it was. So. Oh, it's okay. Can't answer it. So, okay, input file. So I'm going to use camel case for this. This is defining the thing that the data is going to come out of. What we're going to be able to do is after we associate this variable input file, which is of type what? IF stream. After we do that, we'll be able to just read data out of that input file just as if it were CN. Yeah? There's some magic going on here, okay? And the magic will become more apparent as we go on throughout the semester. So, right now it's just magic. You can accept that there's something called IF stream that is a variable type that's provided by fstream. And then if you do the magic stuff we're about to do, you will get data out of a file. Everybody willing to accept that? Okay. All right, now, did we initialize input file? We didn't, and it's sort of okay in this case. Okay? You can initialize it all at once if you want, but I'm going to show you just a different way. Okay, so now we have asked for the file name, and what we're going to do is associate this input file, which is an IF stream, which we're going to get data out from, with that file, that the name that the user gave us. Okay? Everybody with me so far? So what we have to do is we say input file. And what do you normally do with a file before you use it when you're working with it? Save it's what you do when you're done. What do you do when you start? You open it. So dot open. And then in here, we put the file name. Okay. All right, so we've typed a bunch of stuff, haven't we? It would be good for us to check. It would be good for us to check and make sure what we're doing is working with the compiler before we get too far down the road. Everybody agree with that? Did you learn to do that during project 1? Did you compile relatively frequently instead of trying to write the whole thing and then work out all the errors at the end? Okay, so here we do, let's try this. G++ file read.cc.o file read. And we're going to compile the program. The program we're compiling is file read.cc. -o means instead of putting it in a.out, put it in this file named file read. Ready? Oh my God, that worked. All right, great. All right, so now we should be able to read from a file. The only problem is that we didn't set up a file for us to read from, did we? So let's make a file that we can read from. What I'm going to do is I'm going to open a second window here. That's called input data. I'm going to make the font bigger so you can see, and we're just going to have a couple numbers in here. Just like that, okay? So there's our input data. It has two floating point numbers, 12.7 and 4.3. Everybody good with that? So that's the input we're going to read. So now we need to read those two numbers. So what we can do, I hope, is can just read from the input file as if it were CN into two variables, number 1 and number 2. Yes? We're going to tell the program where the file is when we do this input with the file name. Okay? I understand your concern. There's a little bit of magic behind it, but we'll do the easy thing today, okay? All right, what type are num1 and num2? What? How do you know that they're float? In this program, how do you know they're floating point? We don't. And why do we not know that? Because we haven't declared it, right? So let's go up here and we'll declare some variables. What type are they going to be? How many of you say no? How many of you say float? How many of you say double? Good. That was a trick question. Double. All right. So we should read from the file, and now we can output what we read, and that should work. Maybe. All right. I'm laughing because I totally didn't expect this to work. They've changed the compiler on me again. So, all right. Should we compile and make sure this still works? Hang on a sec. All right. Apparently it works. Who's ready to run it and see what happens? All right. So here we go. File read. Oh my God. Yay! That's amazing. All right. That was pretty easy, wasn't it? Okay, what was I expecting it to be? In the old days, the compiler did not like it when you put a string in there. It did not like it. Okay? Some compilers may still not like it. Here's why. What language are we programming in? What languages is this descending from? Before, the compiler would not let you use a C++ string here. You had to use what is called a C string. C++ uses different string types than C, like the internal way that the computer represents the strings are different. So it used to be that you couldn't just put that file name there. This is going to make things so much easier. This is great. And you had to do this instead. You had to put this after it, which would convert file name to a C string so that open would understand what was going on. That's what it used to be. And let's see if that works. It still works, right? It looks like they made it work either way. So this is awesome. This makes our life easier. We're happy. Yes? Okay, so again, the question was, will this work in Nano? Okay, Nano is the editor. It is what you manipulate the text with. G++ is the compiler. So the question is, on CS class, will that work with G++? And the answer is, I have no clue. I didn't test it. Should we look really fast and see? I'll tell you what, when we take a 1-minute break, I'll transfer it over instead of you watching me mistype my password 8 times and get out my 2-factor authentication on my phone and stuff like that. Okay, so that's awesome. That went really fast. Now we know how to read from files. Yay. Okay. Any questions so far? Yeah. Oh, well, if we add a next line, we can just go to the next line. So what do you want numbers do you want to be on the next line? You don't want any numbers. What? 3.2, and what is the second one? 123.7. Okay. So the question is, how do we read the next one? Well, here we go. That's it. Now we have 4 numbers to read. See if that works. Perfect, right? Yeah. Okay, so the question is, I'm totally misleading you, right? So in that data file that I showed you, like the Lima subjects.txt, how many lines were in there? A lot, right? About 100. Maybe, I don't even know how many lines. We'd have to look and see. There are over 100 lines in there, okay? So, and each line has how many variables? So we need at least 1,300 variables. How many of you all want to type 1,300 variables? Nobody wants to do that. Like, programmers are really lazy, right? We are lazy, but we're lazy in a good way. So what we need is some way to do something over and over and over again, isn't it? So that instead of having to do everything ourselves, some sort of construct that would go over and over and over again. Did we talk about that when we were talking about flowcharts? Do you remember I drew something like this? There's a decision. And then you go back to the decision or else you go on, right? So you can do stuff and you make the decision. This is called a loop where you do stuff over and over and over again. So obviously we need what? Great. Let's take a 1-minute break. What I'm going to do is I'm going to quickly transfer this code over to CS class. We'll make sure it runs there without the C string in it. And if it does, when we come back, we will talk about and how to do output into a file. All right, that was your 1-minute break. How you feeling? All right, so while you were kibitzing or doing whatever it was you were doing, I transferred the file read program we just wrote over to CS class. And so here it is, same program we just looked at, right? Do you remember that? Okay, so let's compile this thing and see what happens. Uh-oh. In function main, file read 17, no maxing function call to open standard string and. This is the important part right here. So CS class, the compiler on CS class, does not let you use a C++ string in the file open. This is a problem. Okay? Fortunately, we sort of briefly saw how to fix it. How do we fix it? Yep. Yes, we use magic to convert it into a C style string. And the way we do this, I'll just do this quickly right here, is where we have this file name, where we say file name in there, we put .c_str open close parentheses. What is that? Does anybody know? I can tell you what it is in one word. Are you ready? Magic. It is magic, okay? Now, sometimes I will lie to you and I will tell you things that are not true to simplify it. Sometimes I will just describe things as magic, all right? Because it's easier, we don't need to go into the details. Later in the semester, what magic this is will become apparent to you, okay? Later in the semester, we will learn how to do magic like this. But for the time being right now, we'll just go with its magic. So in the future, when I'm writing stuff, I will always do that because the compilers are inconsistent as to which allow that and which don't. Okay. So how do you convert a C++ string to a C style string? What is the magic invocation that you use? Open close parentheses. .c underscore str open close parentheses. Okay. So let me get out of here because I don't need to be on CS class. Okay. Now I'm going to fix this, and the one that that I will post on Facebook, Blackboard. Didn't I already warn you that I would call Blackboard Facebook? Okay, and I'll put a little note. We don't necessarily have to use that, but we will. Okay. All right, so there we go. We are able to input 4 numbers and output them again, which doesn't do us much good. Because when it comes to reading files, we don't always know how much stuff we're going to read at once, right? We may have to read a lot of stuff at once, an indeterminate number of stuff. So let me just set up a new file here. And we're going to look at how to do that. What we're going to have, and the first thing we're going to see is a loop that's called a while loop. And it looks like this: while, and open parentheses, some Boolean, and a close parentheses, open curly bracket, close curly bracket, and in here, some statements. Now, you all remember when I talked about the notation that I was going to use to describe commands, right? What is stuff inside the angle brackets? Somebody said optional. That's not quite correct. Try again. Pardon? A variable. It's something that you can replace, right? So this whole angle bracket, Boolean angle bracket thing will be replaced with literally some Boolean, something that is either true or false. It can be a comparison. It can be like equals equals. It can be some other stuff. And then we have some other statements. The statements are what is known as the body of the loop, what are known as the body of the loop. Okay? So the body of the loop is the stuff that gets done over and over and over again while that Boolean condition is true. So let me give you an example of this. While true, is true a Boolean? Is true a Boolean value? Yes, it is. While true, see out Clay rules. All right. What is this program going to do? Yep. Let's see if that's right. All right, and we'll run it and see what happens. Woohoo! All right, how long should we wait for this to finish? Until 12:15? Yeah, this would get kind of boring to watch it run all the time, okay? This is what's known as an infinite loop. It does not ever terminate. It will go on forever and ever and ever and ever and ever. Anybody happen to know Apple headquarters address? Apple's headquarters address is one infinite loop. It's a joke. So they have a circle, they're at one infinite. All right, come on. All right, so this is running and running. Now, I did this on purpose. I wanted it to run and run and run and run because when you are working in your programs, you might sometimes, by accident, create an infinite loop. In that case, you have to know how to make it stop. Anybody know how to make it stop? Would yelling at it help? Stop! Nope, that apparently doesn't do it. How do you do it? No, I mean it's running right now. Literally, how do we make this thing stop? We could close the window. That's really annoying because then we have to open it again. So, yeah? I showed someone this yesterday. Yep. All right, what you do is you hold down the button on your laptop that says Control, and you push C. There you go. And it stopped. Okay? Control C will tell your program to stop and make it stop, even if you're caught in an infinite loop or something like that. Okay? Yep. If it's waiting for a value or input, Control C will also make it stop. So Control C makes things stop. Yeah? It's the same on CS class. So if you're working on CS class. It might be the same on a PC. Nothing against PCs. I play games on them. They're fun, but I don't know. I don't program on them very much. So. Okay, everybody good with this? Great. So that was not a very useful loop, right? Fake news all over the place. But we could do something else, right? How about this? How about we say int a equals 0 while a is less than what? How high do we want to count? 6. Then we do a equals a plus 1. So what is our algorithm going to do here? What is this loop going to do? So what's the first value of a? We go down to the while loop. Is 0 less than 6? Great. A equals a plus 1. How does this work? A is plus 1 is, which gets stored where? In a. So what's a now? Okay, now what do we do? Back to the while loop. Is 1 less than 6? You sure? Okay. So we go down here. This a is 1. 1 plus 1 is. A is now. We go back where? While loop. Is 2 less than 6? What does this line do? Adds 1 and makes it 3. You get that, right? 2 plus 1 is 3. We store 3 back in the box named A. We go back here. Is 3 less than 6? Add 1, it's 4. Is 4 less than 6? Add 1, it's 5. Is 5 less than 6? Add 1, it's 6. Is 6 less than 6? How about for really small values of 6? No, it's not. So what happens here? What do we do? We finish the loop and we go to whatever line is down below the loop, which in this case is return 0. Okay? So let's actually put something in there just to watch and see if that's really what's happening. Okay? We'll see out A. And then we'll put a couple of things here. So we can say see out before the loop. And then down here, we'll put after the loop. So when we know we're done. Okay. Everybody good with this? So let's compile it and see what happens. And when we run it, we have before the loop, it prints out 1, 2, 3, 4, 5. Wait, 6? And then after, why did it print out 6? I thought we were going to stop. All right, let's just take a look at that. How many of you are surprised to see 6 there? All right, well, let's look what happens if we step through here. Say right now A is 5. We've been running for a little while and A is 5. Everybody good with that premise? All right, is 5 less than 6? What is A? A gets replaced by 5. What is 5 plus 1? We store that back in A. What is A now? Uh-oh, now the output happens. What are we outputting? Why? Because that's what's in the box labeled A. Okay? And then it goes back and it checks again and says, oh, A is now 6. Is 6 less than 6? How about if the 6 is really, really small? Really, really small values of 6. No? Okay. All right. And then it says after loop. It terminates and it goes down here and says after loop. So it prints out the 6 because the addition happened inside the body of the loop, and it gets printed out before the comparison happens. Okay. Now, I'm making jokes about very, very small values of 6, okay? But it's not always a joke. If you use floating points in comparisons like this, you can get weird results, particularly if you use equals equals. Because is 1 equal to 1.000000001? It is not. And so sometimes you will get some, if you're using doubles or floats, sometimes you'll get some weird decimals down at the end that you don't expect, and strange things will happen. Mostly that happens with equals equals and not with less than signs. All right, so who feels comfortable with this? Does this make sense, right? It's kind of like an if statement where if it's true, it does the if statement and then it just does it all over again. Yeah, Grace. Well, it depends. It depends, right? This is just an example. And what's going to happen is that this loop will never run when a is 6 or greater. Like the body of the loop will not execute. Does that make sense? However, at the end of the body, at one point, a will be 6. It will be, right? But now, if we didn't want to see that, if we wanted to be less confusing, what we would just do is put the C out before the A. And if we do this, instead of notice that we had 1 to 6 there. If we move the loop there, we will get 0 to 5 instead. And the reason is because Cout is displaying the value of A at that moment. And before we were adding to it before we displayed it. Now we're displaying it before we add to it. Okay? See the difference? Yeah. No. The question was, if we make A a floating point value, will it become an infinite loop? The answer is no, probably not. No, it wouldn't, because it's a less than, right? Do you really want me? I'm not going to go down the floating point. I'm not going to go down that. That path lies madness. Okay. Seriously. Okay, just don't use, the rule of thumb is don't use equals equals for floating point. But it doesn't apply to this project, so we're not going to talk about it. All right, everybody kind of see this? Yes, no, maybe? Who's with me? Who's against me? Good. All right, so this is all very nice. The idea of this is just to show you how the while loop works. Do you all feel relatively comfortable that you can sort of see how the while loop works? Yes? Everybody who says yes, yes. Everybody who's unsure. Any questions? 17-second rules in effect. 17, 16, 15. 4, 8, 9, 2, 0. Okay, time's up. Any questions? All right. Silence is assent. You all owe me $100 each. I'll never get tired of that. Okay. So, what we're going to do now is we're going to look at how we use these while loops to read from a file. All right? Because we talked about before, that was one of our problems. So let's create another file. I'm going to call this one while read.cc. All right, so here's our file. And I'm going to have to use a couple of different things. I'm going to have to include fstream because we're doing input and output. I'm going to have to include string because we need to read a file name if we want. Everybody with me on this? And here's what we're going to do. And you know what? Hang on a sec. I totally screwed this up. I'm going to instead copy our while.cc to make it whileread.cc. All right. So we're back here. We've already seen all this stuff before. Sorry, I screwed up again. One more second. I'm going to copy the file read.cc to whileread.cc. And then we will manipulate that file instead. Because I already have a lot of this stuff in here. Okay. All right. So everybody remember this program from a few minutes ago, right? This was our algorithm. We declare a file name. We declare one of these magic IF streams that's going to be the conduit for data from the file into our program. we declared these 4 numbers, asked for a file name, we read it into a string, we do input file open, file name .c underscore string. Why did we need the .c underscore string? Exactly, to convert from a C++ string to a C style string, because the compiler on CS class doesn't like it when you have a C++ string there. Okay, then we read from the file and we output some stuff. All right, what we want to be able to do now is, instead of having to count and read every single variable that's in that file individually, because that sucks, right? What we're going to do is we're going to read numbers. I don't know, do you want to read them? How many? 1, 2, 3, 4 at a time? Your choice. 1. Okay, I heard nobody say 1, so I'll go right with that. So here's what we're going to do. We are going to set up a loop that looks like this. While input file into num1. Okay? And in the body of the loop, we're going to see out num1 indl. Now, it turns out that this thing, input file into num1, is a Boolean. It is a Boolean. And here's the way it works. If input file manages to stick something in this Boolean into number 1, it manages to put something in there, the whole thing is true. If, for some reason, input file is not able to read something and put it in there, like, for example, it ran out of numbers in the file to use, it will return, the answer is false. Okay, it'll return false, okay? What will it return? All right, low energy. Okay, and then what happens down here is we input what? Output what? Just the number that we read. Just the number that we read. So our algorithm now is, we're going to read a number from the file. If that is successful, then there is a value stored in this variable num1, and then we will print out what we got in num1. We will go back to the loop and we will read again. If we are successful, what will happen? Another number will be in there, yes. So, hang on one second, let's just see if this works. If I made any errors while I was compiling. Anybody want to predict if I made any errors while I was Yep, it sure will. All right, so no errors. So let's just run it and see what happens here. Input dot data. All right, so it output 4 numbers. It output 12.7, 4.3, 3.2, 123.7, and then it outputted this whole thing right here. What is that whole thing right there? Okay, what we saw, just to remind you, here is our data file. We do have 4 numbers in there, the ones that we saw. And then what happened is we read each number one at a time and put it in the variable num1, which was outputted. And then after the loop was executed, it output this whole line, num1, num2, num3, num4. Now, num1 happened to have a value in it because we just read it out of the file. It was the very last number in the file, which was 123.7. But what happened with num2, num3, and num4? Yeah? The values in these had not changed since the beginning of the program, so they were all 0. Everybody see that? What do you think? Easy, hard? You all are like being very neutral and quiet today? I'm worried you're plotting against me. Yes? Got it. Okay. So the question is, how does this work, right? Because we have one number, then another number, okay? What I'm telling you, and what I can't easily show you right now, so you'll just have to take this on faith, which is, I understand, really difficult when you're talking to me, like you should never believe anything that I say whatsoever, but I'll just have to ask you to take this on faith, is that when you do this, input file into a number, that it is a Boolean that is true if it was able to put a number in there, and false if there were no more numbers to read from the file. Okay, does that sort of help? So what happens is this input file thing, which is an F stream, goes and opens the file and starts reading it just like a human were typing it, like if we were typing it with CN or something. So it does the exact same thing. It says, oh, the first number is 12.7. I will see that, and then I will stick it in this variable num1, and then we'll output it. And because we were able to put something into num1, the loop was true, and it goes back and it does the loop again. But what happened is, like, the first time it saw this 12.7, right? Hang on a second. So here I put the code and the numbers side by side. So we can make that a little wider. I don't think I can make that wider. But here's what's happening in this loop, right? It says the first number is 12.7. It puts that into num1. It outputs num1. Goes back to the loop. It says, okay, I'm supposed to read another number. What number has it already read? So where does it go from there? 4.3. Just like CN, remember? Like CN will look ahead and try and figure things. So is 4.3 a float? So there's no problem. Puts it in num1, outputs it, comes back up. Okay, now what? 3.2, is that a valid floating point number? It is, so it gets put in num1. It outputs 3.2. Since we're able to read something, we go back and do this again. Now what happens? 123.7. It outputs 123.7. It comes back up here, and it tries to do input file into num1, and then what happens? There are no more numbers. There are no more numbers. It can't read anything else. So this whole thing, input file into num1, becomes false, not true, and it does not do the loop. Instead, it goes down here to the next line after the loop, and it keeps executing from there. So then it will go do this C out, and it'll say num1, num2, num3, num4. Yes? Yes. Okay. So what it's doing is every time it reads something from the file, it puts it in the box labeled num1 in memory. And it overwrites that every single time. Num2, 3, and 4 were set to 0, and nothing ever changes in there, so at the end they are still 0. Is that what you were saying? Yeah? Mm-hmm. Yes. It will break. Well, if we put a character or something in there, it would break. Just like CN breaks, Fstream can break. Okay? But you're not going to have to take care of that in this class because it gets a little too complicated. Yeah? Nope. Because CN, this angle operator right here, skips spaces. It skips spaces. Like if we edit this file, we put like a whole bunch of spaces and a whole bunch of returns, because returns are also white space, and we run it again. No problem. That the angle thing here eats up all the spaces. Yep. Nope. They can be anything. Okay? When we have these files and they have something dot at the end, for the most part, the dot is not for the computer, it's for us, right? So some programs are programmed to only open files that have certain things on the end, just because bad stuff can happen if not, but really there's not much requirement for them to mean anything. Yep. Yep. That would be these numbers up here. Right? Nothing changes unless you explicitly change it. Num2, 3, and 4 are never being touched, so they will always stay the same. Everybody good with this so far? Yes, sir. Uh-huh. Okay. So the question is, if the angle gets rid of spaces, how does it know that it's 12.7 instead of like 12.7? Because it gets rid of them, but you also using them as a separator for numbers. So yes, the answer is how does it know to do that? And the answer is magic. It is magic, yes. Towards the end of this class, maybe not this class, but towards the end of like 052, if you take another semester of this, you would probably be able to write the stuff that FStream does inside. Okay? Right now it's a library. We can just take it on faith. It's nice to take things on faith sometimes and not have to rebuild all the code yourself. Yeah? No, while loop is just inherent. Yeah, you don't need a library for the while loop. Thank you for asking that. All right, I want to do something a little bit different now, in that I don't like getting numbers one at a time. I want to get numbers more than one at a time. How many should we get now? Let's get 2 numbers at a time. If what you are working with is separated by spaces, and we can see that the angle thing can just chomp that space apart, then we could do something like this. Input file into num1, into num2. And each time the angle bracket will go, okay, here's num1, num2, and we can get things 2 at a time. Does that make sense? And so if we run this now, what we'll see is when we output things, instead of getting, one thing per line, one floating point number that we've read from a file each line, we will get 2 each line. Let me compile this. And when I run it, you can see this first time we got 2 things at a time. The second thing we got 2 things at a time. And look, now this last line has changed, right? Because we're printing out num1, num2, num3, and num4. And we can see that num1 had 3.2 and num2 had 12.37. Whoops. Didn't mean to do that. Didn't know I could do that. Yes? Uh-huh. Yep. So the question was, if you had an odd number of numbers in the data file, would it leave the last one off? And my answer is, thank you so very much for setting up the next thing that I would like to show you by asking a question. So, I don't know. Let's find out what happens if we put another number in there. Oops, sorry. Let's put another number in there. So, I'm going to make this a little bit neater. Just, it doesn't really matter if it's where it is. But all right, let's put another number, and we'll call this 8098. 2.3, okay? So now we have an odd number of numbers. What's going to happen here? Any guesses? Yeah. Yes, it should print all of that in 123.7. So let's run it and see if that's actually what happens. Okay, so here's what happened. We got 12.7 and 4.3, which is the first line that we expected, right? We got 3.2 and 123.7, which was the second line we expected, but we did not get a third line with 2 numbers, did we? However, over here, that 982.3 that we had is actually printed out. So let's look and see what happened here. So the first time we ran this loop, it said input into number 1, which was that one, and number 2. It got both of those. Was it able to put numbers into both things? So if it was able to put numbers into both things, what does this whole thing become? True or false? True. So it output those 2 numbers, 12.7 and 4.3, like we saw, right? Then it went and it read, okay, went back and said, okay, I was able to read 2 numbers, so I'll go back here, I'll read 2 more numbers. So it read 3.2 and 123.7. It was able to read 2 numbers. Was this thing true or false? It was true because it was able to put things into both. So it output num1, which is it read 3.2, and 123.7, which it had read no problem. Goes back up to the loop. Reads into number 1. Was it able to do that? Was it also able to read into number 2? No, it was not. So what does that whole thing become? Whoops, sorry. This whole thing becomes false. But did it still manage to put a value into that variable num1 right there? It did. It did. So num1 changed, but because we were reading two things at once, and we only got one number, the Boolean condition here was magically false. And so it came down here and it printed out everything, and we were able to see that num1 was actually this large value right here. Okay? So it read all the values. However, because it didn't read everything it was supposed to on the same line, it did not enter the body of the loop. Everybody with me on that? Yes? Can I repeat? Yep, I can say that when it only read one number, this input into num1 into num2 right here inside the Boolean condition of the the while loop, was not true. It was false. Even though it was false, num1 still had its value changed because it was able to read that. It's just because it wasn't able to read both, it goes, oh, I'm out of numbers. I'm going to give up now. And so the while loop doesn't happen anymore. Yeah. It's doing this whole thing. Yeah, it's like oh, I'll put number into 1, I'll put number into 2. Now I'll figure out if this whole thing is true or false. Yep. That's kind of the order of operations there. So, yep. So when we're dealing with like 1300 numbers, are we doing like num1, num2? Okay, so when you're dealing with the data file you have to read, what does each line in the data file look like? Would it help if you had it up to see? Would you like me to put it up so you can see? Okay, so here's what we have to read in the data file for the project. Okay? And I highlighted one line there. How many values are in that line? 13. What are their types? Int, float, int, float, float. So you have to read 13 values. You can do that all at once. And you know why you can do that all at once? Because they're all separated nicely by spaces. And because you don't have like a whole string you're trying to get something. Right? So in your loop, in your program, you can read all 13 values at one time. Doing it just like I showed you, except instead of having num1, num2, you'll have subject ID, age factor, all the other things. Okay. Make sense? So that is your loop. You'll read. Now, are you going to end up in a situation where there are not 13 things in that line? How many of y'all think you will? How many think you will not? Thank you. I will not be that big of a jerk to you to randomly exclude values. Okay? So the input file will be properly formatted. It will have 13 fields. All right, you just let me talk for like 35 minutes. You all ready to stand up for a second? Why weren't you screaming at me before? Be like, Clay, shut up. Give me just 1 minute to stand up, stretch. Stand up, stretch, come on. So it's not doing the body of the loop. It's that there's another print statement after the loop ends. And so it's printing after the loop ends. So it didn't print the one inside, it printed after. All right, people who are not standing up are subject to random candy bombing. Oh, sorry. Oh no, sorry, they're a little too late. There we go. Psych. All right. Feeling better? All right, so actually, as of right now, as of today, you have everything that you need to write the whole program. You do, except for a couple of tricks, and I can show you one of the tricks, and then you'll have everything you need to write the program. All right, and that's going to be nice for me too, because then we can go back to like talking about stuff at a little more leisurely pace, and we can do some more fun stuff like those in-class worksheets and stuff like that. We haven't been doing as many of those because I've been just trying to get you to the point where we can do the code. All right. Okay, so there's one other thing. Let me ask you a question here. Let's say we're running this program, and here's what I'm going to do. I'm going to change things up a little here, and I'm going to add some more numbers to this data field, okay? But before I do that, I'm going to turn off the projector so you can't see what I'm doing. Ha! All right, so I just added some extra stuff to the data file that you weren't able to see. How many lines are in the data file now? Anybody? Got a mini Snickers bar here if you have the right answer. I can't look without showing you now. I'm in trouble. I don't think it's 14 though. So there's some number of lines in there, okay? I hope the projector comes back now. I am too clever by half, aren't I? Hello? Okay. So we want to know how many lines are in there. How are we going to know how many lines are in there? Yeah? Yes, we can. Absolutely. So let's I'm going to create a new file called whileread2 just so that when I upload this, it'll be a little bit different, okay? All right, so here we have a program that is reading things from the file 2 numbers at a time, all right? What we want to do is we want to see how many things we're reading from the file. So what I'm going to do instead is I'm just going to make it so that input file is only reading one thing at a time. Okay, just like that. Do you remember we were doing this before? Right? The only thing that's changed is this while loop. We're input file into one variable. We're outputting that one variable. Okay. How would we tell how many lines are in this file? Yes, I'm back. So, sure. No. You had your hand raised in the hat. What's your name? Ryan? Did you raise your hand? You tell us. Okay. Do you have an answer there? A counter that counts how many times. So we can do something like this. We can say int line count. And where do we start with? Like about 12, probably, something like that. What? 0? Oh, yeah, that's probably better because we don't know how many lines there are. So far we have read 0 lines. Now what we're going to do is we're going to read things into this number, and then instead of outputting it, what are we going to do? Just like that. Count equals count plus 1. And when we're done, instead of outputting the number, what are we going to output? Man, grumpier than the compiler. All right, is that better? So what is our algorithm now? Our algorithm is very similar to what we had before. Ask for a file name, read the file name, attempt to open the file, right? And then start reading things into the variable. This time though, the body of the loop, instead of outputting what we're reading, is incrementing a counter. That counter gets 1 bigger every time we read something. And then at the end, we output the number of lines. Everybody with me on that? Yeah? I don't know. Do you want to start it at 0 or 1? You should start it at 0. Okay? And the reason is if we started at 1, we're starting with one line before we even counted any other lines, right? So we're just assuming that. So in computer science, as we'll see later in the semester, computer scientists really often start counting things from 0. And this is the reason why. One of the reasons why. It'll show up again later. Okay? All right, so how many lines are in this file? Any guesses? I don't know why you're not guessing. 10. There are 10 lines. You're all wrong. Ha 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 ha. All right, so there were 10 lines on there. Right. And if I show you the file, you can see that there were 10 lines, right? I just added some numbers down at the bottom. Oops, I forgot to put it in line there. So. Okay, so now we can count the number of lines. There's one other thing that we might want to be able to do with these numbers. What if we wanted to add up all the numbers in the file? How would we do that? Yeah? So you want to declare what? A variable called sum. And what value do we assign sum initially? You sure? It's going to be a lot bigger than that when we're done. All right, so we'll start at 0 because right now, as far as we know, it is 0. We have not read any numbers from the file. We do not know what numbers are, so it's currently 0. Okay? Then what do we do down here? Yep. Sum equals sum plus num1. All right? So here's what we're doing. We are setting this sum to 0. The sum is going to be a variable that holds the sum of every number that we have read in. How many numbers have we read in when we start the program? How many? 0. We have read in 0 numbers. What is the sum of 0 numbers? Are you sure? Always? If you add 0 numbers together, will it always be 0? How about for really big values of non-existent numbers? Yes, it will always be 0. Okay, so we start at 0 because we haven't read any numbers. In this loop, hopefully I have proven to you by outputting before each time this loop executes, we will read one number from the file. We will take that number that we read, we will increment our line count because we read one more line, and the number will be stored in here. So we will add it to sum, and then replace this whole total of sum plus num and put it back in the box named sum, because that's the sum of all the numbers we've seen so far. So when this loop executes, right, it reads a number in, it says, oh, so far we've seen sum, which might be 0 the first time. We'll add the number that we just read into it, and the result of this will be put back in sum. It will be some larger, unless we have negative numbers, some larger number than before. And then when we're done, what do we want to output? Sum, like this. All right, we'll see if that works. What? Who got me first? Who was the first one who said that? You were? Claire. It's like a little kid. Here. Try again. Okay. All right. You all are like the least excited class I've ever had about the candy. Literally, most of you are like, anyway. I don't know, I'm going to have to get donuts or something instead and see. Pizza? I'm a little worried that pizza won't fly very evenly. Yep, it's like slice. All right, so let's see if that works. And honestly, I'm just going to tell you, I have thrown donuts in class before. I would be happily do it again. All right, so what's going to happen when we run this? Input a file name, input.data, and it says we have 10 lines and the sum is 10,403.2. How would we compute the average if we wanted to compute the average? Yep, divide the number, sum of numbers by the number of lines. As of right now, you have all the code knowledge you need to write the next project. Congratulations. We're like weeks ahead, okay? So if you wanted to go ahead and do the design and start working on the code, you can. I have not set up the autograder, and it won't be ready until next week. So you can get a head start if you want to start very early. Yes? No, you will have to choose which numbers to add up. You will read 13 numbers in at a time. You'll have subject ID, age, things like. So for you'll need something that's like sum of all ages, sum of all BMIs, sum of all each. So you need some variable to keep track for each field.
We're going to have access to the file.
You're going to have what? Yeah, you can download. You can just click on it and download it. You can bring it on your computer. It's in my account on CS class. You can run it from there. All right, I want to show you one more thing. I feel like I'm at an Apple thing. Okay. This operation we have right there, the ones I've highlighted in blue, line count equals line count plus 1, and sum equals, well, actually, I take this back, only line count. This operation where we do line count equals line count plus 1 is super, super common. We do it a lot, because we have a lot of loops and we're often counting things inside loops. So there is a special operator for this, and is known as the increment operator. We'll talk about this more. So I'm going to comment that out, and instead I'm going to do it this way. Line count plus plus. If you put a double plus after a variable, it will make that variable one bigger inside its box. Okay, it'll make it one bigger inside its box. So this right here is really exactly the same. These 8 something, these are the same. Okay, line count plus plus is the same as saying line count equals line count plus 1. Except what? Less typing, right? Less typing. Geeks are lazy. Yes? Does the increment work on a floating point number? And the answer is I don't know off the top of my head. Typically, it's commonly used with integers, like almost everything we're counting as integer values. So I'm not sure what happens if you use it on a double off the top of my head. Okay. What's the name of the language we are programming in? What language is it descended from? Plus plus. C, C++. Now you know why C is named C++, because it is an incremental development of C based on the increment operator. Computer scientists, we just kill people with our humor, don't we? It's total, just slay everybody. All right, so good luck. Have a nice week. I will not see you until next week. Go ahead and get cranking. You have everything you need. I will go back and upload all this code to Blackboard. I apologize if anybody tried to look from the code from last class. I forgot to upload it, but I will get it all up on Blackboard.